Hello all, I want to show you in this video how to calculate voltage drops and R total and the current in the problems like this. So this is what we need. We need R total, and I need current, and I need V of R1, and I need V of R2. That's voltage drops. And I don't really know how to do the subscripts over here, so unfortunately they're not going to have subscripts, but pretend that R1 and R2 are subscripts, okay? So I need to find all those quantities. So how do I go about this? Well, I'm always looking for my 4 steps. First, I need to do the conversions. Well, I don't need to do any conversions. Everything is in engineering notation. I have 200 ohms here. I have 300 ohms here. I have 5 volts here. No need to do any conversions. Next one, I need to find the formula I will actually use. So I need the formula for R total. Well, this is just 2 resistors in series. I have R1 and R2. The one right after another, like beads on a string. So all I have to do is add them up. So that's going to be R1 plus R2. I can move this up. There we go. All right, I've got the formula I can calculate. So my R total is going to be 200 plus 300 ohms. So this is just 500 ohms. Notice that I'm capitalizing ohms if I'm actually spelling out the words, just like I would capitalize amps and volts, because they're all last names of scientists. Okay, well, this is just one of my answers. This is just my resistance. Now I need to find the current. Now when you think about the current, it's a bit of a trick. We do know Ohm's law, and Ohm's law always tells us the current based on the voltage drop of that particular resistor and the resistance of the resistor itself. But we don't have a voltage drop for R total, do we? As a matter of fact, we do. We can rewrite this particular circuit diagram like this. Here's my battery. And I will say that I have only one resistor. But instead of 200 and 300, I'm going to have, it's going to be exactly 500 ohms. This resistor is going to be R total. And this is still the same battery I've had. Now notice that this particular circuit over here will have exactly the same current flowing through it as the circuit over here. This is something called an equivalent circuit. Its voltage and current are exactly the same as the circuit above. And the resistance, the total resistance is exactly the same. It's the specifics that are different. Over here, they're broken up in 2 resistors. Over here, you have just one. Well, when we have something like this, we can actually use the KVL. We know that these 5 volts have to be used up in this circuit. And we also know that there is only one place where we can use them, and that place is right here. So voltage drop of R total has to be 5, otherwise it's not going to work. Well, if voltage drop of R total has to be 5 volts, and we know that this is because this is the voltage of the battery, then we can actually find a nice formula for our current. Because current is just V over R. So voltage of the battery over R total is going to give us the current flowing in this circuit and in this circuit, because I told you they're equivalent, they're exactly the same. Okay, I've got the formula. I derived my formula nicely. So now I can apply my formula. So this is going to be just 5 divided by 500. Well, this is the same as 1 divided by 100. Because I'm canceling out something over here. I'm canceling out 5. I'm canceling out 5. This is 1. This is 100. Got it. Well, there is another way to write this number, and that would be 0.01. And the units are, of course, amps. And now I'm going to go ahead and convert this to a SI notation. So I will get 10 milliamps. All right. Very straightforward. Now I have my I. This is great. Well, what's next? Let's see. I found R, I found I. Now I need to find the voltage drop of R1. Now I want you to remind you what voltage drop is. Voltage drop is the amount of voltage a charge has to give, it has to spend to get through that resistor. So if you remember, when the charge gets out of the battery, it has exactly 5 volts. It's going to spend some in here, we don't know how much yet, and then it's going to have less over here. Well, let's try and find this out. Well, we can use Ohm's law again, and let me draw my triangle. I've got V over I times R. And I'm going to block out V, so I end up with I times R. Okay, so this is going to be my formula. Is my V equals I. And I have only one current in here because I have only one loop. There is no place for the current to split up. It all goes just in these wires. I times R. But which R? Well, we are looking for the voltage drop of this resistor, so it has to be the resistance of this resistor. So it's, of course, R1. Okay, I've got formula now. I'm going to use it. So, and let me put down that this is V of R1. So I've got my V of R1. And that is equal to, let's see, 0.01. Now notice I have converted my amps to milliamps for my final answer, but when I'm doing the calculation, I'm taking the unconverted form. Times, and my R1 is, let's see, it's 200. Okay, 200. Well, that is just 2. So my answer is 2 volts. No need to do any conversions here. Everything is already converted. All right, so I can label this on the diagram. This is just 2 volts. Well, if it used up 2 volts over here, then it has exactly 3 left. This is 3 volts. And I know that since I have only one resistor left, it must spend all 3 volts in here. So at this point, I can just say V of R2 is 3 volts. But here's the thing. In the practice test, I will be asking you to actually use the Ohm's law to find it, which is why I'm going to use the Ohm's law to find it myself. So V of R2 is exactly, we use exactly the same reasoning as over here. It's the current that passes through R2, this current, because we have only one, times the R2 itself. Okay, I've got formula. Now I'm going to use it. Once again, I get 0.01 times 300. And that gives me 3 volts. Notice once again that my volts are capitalized. So now I can verify that KVL holds. I can say, well, I want to verify KVL. That's Kirchhoff's voltage law, if you guys forgot. So 2 volts plus 3 volts, that equals 5 volts. So we know that the KVL holds. Whatever the battery gave them, that was 5 volts, was used up in the circuit. So I can put down KVL holds. All right. So this is how I want you to do a problem like this when you see it on voltage draw, on the Kirchhoff's voltage law practice test. You're going to have V of R1 and V of R2 and V of R3, and you're going to have 4 resistors in the second problem. But they all use exactly the same reasoning. Just follow along like I did, and you will be just fine.